let's see now what is that Maxwell equation. So Maxwell plays a very important role in just, you can say that, finding the existence of your electromagnetic wave. So all this depends on, the existence depends on your Maxwell equations. So these are the four that you can say that the Maxwell equations based on your four, mainly the laws: the Gauss law of electrostatic, the Gauss law of your magnetism, the Faraday's law of your electromagnetic induction, and that your modify Ampere's law. So which will give you the relation between electric field and magnetic field. So how they are just related to each other. You can't separate electric field and magnetic field in an EM wave. So that is give the relation between your E and B, and how that is changing with time and with the distance in the space. So if we just stop over here, so the Gauss law of electrostatic, you just know that. So we have seen that the electric flux passing through, obviously, so the flux passing through any closed surface is equals to the total charge enclosed by that surface. So I know that. So this is your phi, yeah. So the flux passing through any closed surface, so which is phi is equals to integration of your E bar dot ds bar, which is 1 upon epsilon naught times the net charge enclosed by that your closed surface. So this is what we can say about the electric flux. So that is your Gauss law of electrostatic. Similarly, we can say that the Gauss law of magnetism. So even in the case of your Gauss law of magnetism, so that is the magnetic flux, so which is related to your magnetic flux now, and again which states that the magnetic flux through any closed surface is always 0 over here. So if I just consider a closed surface over here, the incoming magnetic lines of force, yeah, is same as that of your outgoing. So for this case, you can say that the flux through this surface, any closed surface, it is always equals to 0. So I know that again phi is equals to b bar dot ds bar. So for this case, the direction of b bar in this way, the direction of surface is opposite. For this case, again b and ds, they are in the same direction. So obviously there is a subtraction for that, your b ds, again that is a minus b ds, so which is nothing but 0. So you can say that definitely the flux through any closed surface is always 0 for this your Gauss law. Again, for the next case, the Faraday's law of electromagnetic induction. So again it is related to your electromagnetic induction. So induced, the EMF is going to induced in a circuit whenever the flux linked to that circuit gets changed. So how we are going to change? Let's say this is a magnet. When I just move this magnet in the downward direction, you will find that there is a current has been induced. Obviously you can say the EMF has been induced, and which will produces the current. And again the value of that current or EMF, you can write it down, E is equals to minus d phi by dt over here. So this is how you can find the value of your EMF over here with the help of your that electromagnetic induction over here. So this is about the Faraday's law of your electromagnetic induction. So we can say, even if I just take the integration of your E bar dot dl bar around that closed path is nothing but the rate of change of flux, which is linked to that your loop over here. So that is about your law of electromagnetic induction for this case. Even we had just seen that your modify Ampere Circuit Law for this particular case over here. So this, it states that is nothing but already we had just calculated it, that your integration of b bar dot dl bar, so which states that your mu naught IC plus your mu naught into that is a ID. So that is the statement for your Ampere's Circuit Law, that is the integration of b bar dot dl bar is equals to, which is mu naught IC plus mu naught ID over here.